Can we easily identify all prime numbers? Have you ever wondered if we can easily identify all prime numbers? Prime numbers are special natural numbers greater than 1. They have no positive divisors other than 1 and themselves. This means that a prime number cannot be divided evenly by any other number. To determine if a number is prime, we check if it can be divided by any smaller number other than 1. For smaller numbers, this can be done using a method called trial division. You only need to check divisibility up to the square root of the number. This is because any factor larger than the square root would pair with a smaller factor that you have already checked. However, as numbers grow larger, this method becomes less efficient. For larger ranges or very large numbers, mathematicians and computer scientists use algorithms known as prime sieves. One of the most well-known is the Sieve of Eratosthenes. This algorithm lists all numbers up to a certain limit and marks multiples of each prime as composite. This leaves only the prime numbers unmarked. It is an effective way to generate all primes up to a specific size, but it is not practical for testing individual large numbers. There are also more advanced sieves, like the Sieve of Atkin, which improve efficiency by using mathematical properties and quadratic equations. These methods eliminate composite numbers faster, but they can be more complex to implement. For testing individual primality, especially with very large numbers used in fields like cryptography, specialized tests exist. These tests can quickly determine if a number is prime without needing to check every possibility exhaustively. Despite all these tools, there is no simple formula or method that can directly generate the next prime number from previous primes. The distribution of prime numbers is irregular. While many algorithms can find or test primes efficiently, identifying all prime numbers, especially the infinitely many or very large ones, requires considerable computational effort and sophisticated methods. In summary, while we can identify prime numbers efficiently within certain ranges using algorithms like the Sieve of Eratosthenes and primality tests, there is no effortless way to identify all prime numbers, especially as numbers become very large. The study of prime numbers combines basic number theory with algorithmic techniques, revealing both the simplicity and complexity found in the world of numbers.